whenever you all are ready, could you explain what you've built?
We actually built a video game, and this video game is inspired by Lab 2, the boys algorithm, and also another Crowd City video game online.
Okay.
So it's just some kind of a combined product. And this video game, as you can see here, the initial state is a user interface, and you can choose the time you go into. Say we choose 60 seconds.
Okay.
And after you go into this video game, there are two kinds of boys. One is the free boys, their color is white.
Okay.
And another one is some kind of organized boys, and they have color green and red. And each of these organized boys form a group, their own group. And each group would be led by a leading boy. And the leading boy, you can control this leading boy like this red one or this green one.
Right now you're steering, it looks like, what, the red ones?
Yeah. Move right, move left, up or down.
So that whole group is following that leader?
Yeah.
Okay.
Exactly.
Okay. And if you get close to a free boy, it becomes red?
Yeah. As you can see here, and red, and red, and yeah. And there are also some unfollowing tips. So if the boy is too far away from the leading boy, then it would become free boy then.
Okay.
Yeah.
Like the little smiley face.
And what's
Yes.
the point of the game? The point of the game is to maximize the size of your group.
Yes, so you win if your the number of members in your group is greater than the other one.
Okay.
Oh, but you can subsume the other. So I just saw
Yeah.
Yeah.
red and green got too close to each other. So since red had more members, it
Right.
subsumed all of greens.
Yeah.
Right. And
Okay.
it's also possible to lose boys. For example, if you hit the boundary or something, and then
Yeah. This part would.
yeah, basically the boys can follow their lead if the lead is within their visual range.
Okay. Okay, so if a trailing Boyd leaves the visual range of the leading Boyd, it no longer will follow the group?
Yes.
Okay. Okay. And then I'm hearing a few sound effects, so some beeps. When do those beeps happen?
The beep will happen, say, the red one nowadays are less than the green, and once its number is passed or is over than the green one by a certain amount of number,
Yeah.
say 2 or 3, then it has an obvious win number, then we will make sound to indicate that now the winner is changed.
Okay. Okay.
And also there's another sound effect. If the time remain is less than 5 seconds, then it will generate an alarm sound.
Okay.
Yeah, that to tell you the time is going to end.
And it looks like, am I correct that sort of the rules that the Boyds are following are the Boyds that are a part of a group following a different set of rules than the Boyds that are wandering around?
Yeah, so basically these boys normally will not, like the free boys will normally won't change its direction. So they're initialized with a random position and direction and velocity, and they're just keep moving in that direction. However, like at each update, each boy will have 1% chance to change its direction.
Okay, I see.
Yeah, otherwise it's I think it's just adding some randomness in this program.
So the free Boyds are just sort of randomly moving around, occasionally changing their directions?
Yes, and also they follow a rule when they hit the boundary of those obstacle boxes.
Yeah.
For those that are not moving, it's just if it hits on
More time.
yeah, if they hit it and
Yeah.
from one direction, then this direction, their motion in this direction will become 0.
Okay.
And that's why these boys are moving horizontally, because when they hit it, they lose their velocity in X direction.
Okay.
And boys touching the moving wall, they will bounce off.
Okay,
in-
I see.
in
Yeah.
different direction.
Yeah. So the ones hitting here are having their velocity in that direction reversed.
Yes,
So like that one just bounced. Okay.
right.
And then the ones on the bottom are having their velocity in that direction zeroed, so they end up crawling along the bottom.
Yes.
Interesting. So then, and I'm noticing too, like here, some boids will leave that, yeah, like that boid just left that group. So gameplay strategy is sort of, you want to capture as many free boids as you can, and if you're winning, you also want to move towards the opposing group. If you're losing, you want to try to stay away.
Yes.
Is that right? Okay.
Right, and you cannot move too fast or change direction too fast, otherwise like the boys cannot follow you. They'll just
Sure.
sneak through.
Okay. So you're trying to keep all your group with you as well, so you can't be totally erratic. What an interesting game. Oh wow, that was
Right.
very cool. And then the sound effects, are those being generated via direct digital synthesis?
Yes.
Okay. Okay. Very nice. I like your game board.
Thank you.
I particularly like this one.
Yeah, right. I generated this heart using some cosine and sine functions.
Okay.
And then I fill the. It's actually interesting to actually fill the heart because it's easy to compute the boundary. So I basically created a array that, like a square array or a rectangular array that is of size 100 by 100. So like the heart could be fit inside that array.
Okay.
And then, so I first compute the boundary, so I know which points, like which pixels that are the boundary, and then I just loop through each column, and from both top down and down to the top, so that when I hit the boundary, I'll set everything before that to red, and when I hit the boundary, I'll set everything before that to white.
Okay.
So and
Interesting.
then-
So you didn't hard code all the pixels that compose the heart. You figured out algorithmically how to
Yes.
generate the heart. Okay.
Well, it's a stupid algorithm.
Well, it makes a nice heart.
That is tedious.
Very, very nice. It's a really interesting game and a cool application for the Boyd's algorithm. Really, really nice. Thank you.